Welcome back, Cubs. In this video, we're going to be going over percent yield. We'll do a practice problem as well in this video. So percent yield is taking into account the theoretical yield. This is determined mathematically, and this is the actual yield. So this is how much is actually, how much product is actually produced at the end. So it can give you some information about the overall efficiency of a particular reaction. So theoretical yield, this is determined mathematically by doing just a basic Stoich problem. Actual yield, this will be given to you in the problem. The actual yield will be given to you in the problem. So let's take a look at this problem here. We have percent yield. Aluminum reacts with excess copper to sulfate with this reaction here. If 1.85 grams of aluminum reacts and 3.70 grams of copper, what is the percent yield of the copper? So before we do this practice problem, let's just do a quick recap of the types of questions that you'll be seeing. So if you are presented with one reactant, so one reactant in your problem, that's going to be a basic Stoich problem. So that's going to be mass, 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 mole, mole, mass, or mole, mole. So if you just have one reactant, it's just going to be a basic Stoich problem. If you are presented with two reactants in your problem, two reactants, then that's going to be a limiting reactant style problem. Refer to the other videos on how to solve those. Let me know if you have questions. And then if you're presented with one reactant and one product, that's going to be a percent yield style problem. So one reactant, it's just one of the Stoich problems. Two reactants, limiting reactant. If it's one reactant and one product given to you in the problem, then that will be a percent yield style problem. So let's take a look at our sample problem here. We had, go back to the PowerPoint. So our balanced chemical equation, remember, we want to make sure that our equations are balanced. Why? Because we need to use the coefficient in the stoichiometry problem. So the coefficients need to be correct. We also want to write down the numerical values given to us. 1.85 grams of aluminum, that's going to be a reactant. And then 3.70 grams of copper. We can see that copper is a product. So since we've been presented with one reactant and one product, that means that this is going to be a limiting reactant problem. Sorry, a percent yield problem, percent yield. When you have a reactant and a product given to you, it's going to be a percent yield problem. So when we're given the product here, this is our actual. Then we use this value to mathematically find the theoretical yield. So we're looking for our unknown in this case is going to be grams of copper because we're given grams of copper, the actual. So to find the theoretical, we start with our given, 1.85 grams of aluminum. Whatever this unit is, it's going to drop down to the denominator. Now we can go to moles of aluminum. From moles of aluminum, that unit drops down. We can go to moles of copper. Then from moles of copper, that drops down and gives us grams of copper. So we have set up our mass to mass stoichiometric calculation. This is going to provide us with the theoretical yield. We'll use both of these values in a moment. So let's calculate this value, mole and gram together. Mole gets the 1. Gram, we're going to use the value from the periodic table, 26.98. Mole over mole, use the coefficients. That's why we need a balanced chemical equation. So we have a 3 for copper and a 2 for aluminum. Gram and mole together, mole gets the 1. Gram, you get the value from the periodic table, 63.55. So this is a pretty straightforward mass-to-mass stoichiometry here. We have 1.85 divided by 26.98 times 3 divided by 2 times 63.55. So we end up with 6.54 grams of copper. Remember 3 sig figs there, gentlemen. So the equation for percent yield is going to be the actual divided by the theoretical times 100. So that means for this problem, the actual given to us in the problem, 3.70 grams of copper. Remember, the actual will be given to you in the problem. And then our theoretical, 6.54 grams of copper times 100. That will give us a percent yield. So 3.70 divided by 6.54 times 100. So we have 56.6%. So this is our yield. We have a 56% yield. This indicates, okay, of all of this aluminum that reacted, we only got 56.6% of our expected product. So then you could take that value back to your research team or board of finance and say, okay, how can we improve this value here? Okay, so that's percent yield. Let me know if you have any questions, and have a great day, Cubs.